All right, arcs and circles. We're this marks this is these theorems that we're going to learn are not super difficult, but this lesson kind of marks the shift into we're learning theorems and then we're going to do algebra problems with the theorems, just like we've done for pretty much this entire class, and other than proofs and all of that stuff. And so let's dive in and learn some theorems and do some examples. So remember, first of all, what is a chord? A chord is a line segment that has endpoints, both of its endpoints on the circle, right? So the first theorem we're going to learn is in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So this minor arc FG is congruent excuse me, is congruent to the minor arc HJ if and only if chord FG is congruent to HJ, right? So in this kind of like example, right? And so that lets us make equal equations, right? This equals that. So let's dive into an example using this. Let's do it. Here we go. In the figure, circle J. Now you notice this kind of some new notation kind of. We mark circle by doing a little circle with the little center point in it. And circles are typically named by their center, right? This circle and that circle, whatever. So anyway, circle J is congruent to circle K, and arc MN is congruent to arc PQ. So since these arcs are congruent, that means their corresponding chords are congruent, right? We're looking for the measure of PQ. So the measure of PQ, we're looking for this whole length right there, which would be the same as MN, right? Because they're congruent. So what can we do? Well, we can set these two little expressions equal to each other and then solve those. No big deal, right? 2x plus 1 equals 3x minus 7. Now we can solve this for x. So we're going to subtract 3x from both sides. I usually like to move my variables to the left. I know this is going to give us one extra step, but you know, it'll be fine. We'll live. And then we can subtract 1 from both sides. Those cancel, leaving us with negative x equals negative 8. We've got to get rid of that negative. How do we do that? By dividing by negative 1. So x equals positive 8. Now we need to stop. Wait a minute. Are we done? Do we circle this? No, we're not done because we're looking for PQ, right? So PQ is right here. You could technically plug this into either expression because they're congruent, right? But we're going to plug it into the PQ one just because we could do either one. So we're going to put an 8 in for x right there. We've done this kind of stuff, like I say, all year long. Put 8 right there. 3 times 8 is 24 minus 7. 24 minus 7 is 17. So it is 17 units long. Nice. All right, next theorems. We've got a couple theorems. They kind of amount to the same thing. They're not quite the converse of each other, but they function kind of almost like converses, kind of. So the first one says, if a diameter or a radius of a circle is perpendicular to a chord, so it's perpendicular to a chord, then it bisects the chord and its arc. So what that would mean functionally in this particular problem is that xy, or this particular example, is xy is congruent to, I should do this in a different color than this one just for clarity. XY is congruent to YZ, and the arcs are congruent as well. So XB arc is congruent to BZ arc, right? So that's what that says. So the second one says the perpendicular bisector of a chord. So this, because this is a perpendicular bisector, so both those are labeled, is a radius or diameter of the circle. So what this says is because this is a perpendicular this AB is a perpendicular bisector of XZ, then we know it is a diameter. That would actually be, if we were using our little math compass and all those things to construct a diameter of a circle, this would be how we would do it, right? But as far as the algebra, these functionally give us the same types of formulas we can make, right? We can set stuff equal. Again, let's do an example using that one. So in circle S, the measure of PQR. Now, why does it say the measure of arc PQR? Well, if it just said the measure of arc PR, that could either be this major arc here or this minor arc. So arc PQR equals 98. So all of this is 98. So find the measure of PQ. Now, we know that we know from just looking here that this is perpendicular to this chord, which means it splits it in half. So this TR is 6, which would mean this is 6. We don't really care about any of that because we're only interested in the arc, right? So PQ is half of 98. So 98, just for consistency, let's switch colors. 98 divided by 2 equals 49. So the measure of arc PQ equals 49 units. That's easy. I told you the math on this one's going to be pretty easy. It's not the formulas in the next lesson are going to be a little bit trickier, but we're off to a good rate. Now this is a lot more complicated looking picture, right? It's not much more complicated formula wise. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So we've got chords F, G, and chord J, H. These are congruent to each other if and only if they are equidistant. So XL would have to be congruent to, I don't know what this is, A. AL, right? So if those are congruent, then those chords are congruent. So again, it lets us set up the same kinds of formulas, right? We can set up this equals this measure equals that measure and all of that sort of stuff. So the math and the working out of the problems is going to be really, really similar, right? So, oops. Last example, and then we are through. This is going to be a quick one. So it probably, you know, there's plenty of pausing for you and, you know, all the things, but it's fine. All right. So this problem, I like this problem because it's a little bit sneaky. It gives us a useless number. So let's see what we're talking about. So in circle A, the measure of WX equals the measure of XY equals 22. So it's saying that this chord is congruent to this chord because their measures are equal, right? Because of the definition of congruence. If their measures are equal, then they're also congruent. So since these chords are congruent, that means that the distance to the midpoint is also congruent. So we can just set these two things equal, and we don't even need the fact that it's 22. We don't even care about that. That's like, great problem, but we don't even care, right? So if we can say 5x equals 3x plus, ooh, that was a weird thing, plus 4, right? Now we solve this little guy. No big deal. We're going to subtract 3x from both sides, minus 3x minus 3x. 5x minus 3x is 2x equals, and bring down our 4. How are we going to get rid of that 2? It's multiplied, so we divide to get rid of it. So x equals 2. No big deal. Now, are we done? We are not done. We need to find the measure of AB, so let's plug that in there. So the measure of AB, segment AB, right, is 5 times 2. Takes more time to write than it does to figure out, because you probably already had it almost from the get-go, right? 5 times 2 is 10. Easy peasy. Believe it or not, that's it. That's all there is to this lesson. The next one is going to be a little bit trickier, but we're after all that we've done in this class, I think even that you're going to find pretty straightforward. So we'll see you in the next one. Adios. Have a great day. Bye-bye.